Hey, sorry, I I can't hear. Oh, sorry, I couldn't hear you. I have my nice headphones here. I say they're nice because they're a little pricey, and these are noise canceling headphones, so it makes everything a little bit outside of when I'm listening to a little quieter. Gives me that really good environment, and it's just a funny coincidence that I was actually listening to my noise canceling headphones as I'm going to talk about noise cancellation today. Noise cancellation, which you find in a lot of fancy headphones and equipment nowadays, is actually a concept due to called wave interference. And so today I'm going to talk a little bit about wave interference. So this is what happens: wave interference. Instead of just focusing on one wave, which we've kind of been doing, we're going to be focusing on what happens when two waves or two or more waves meet each other. All right, and a couple different things can happen. All right, so first of all, let's just kind of do it one simple wave at a time. I have, let's say, two waves here. Let's just label these here. Let's say I have, we'll call this wave A, and we call this wave B. And now the nice thing about my little picture I have here is I have them set up on a grid, right? So I could say the amplitude on these ones here. Today we're going to be focusing a lot on amplitude when it comes to sound waves. Now, again, recap first before we keep going. Remember, when we talked about sound, amplitude is how tall a wave is, and it relates to loudness. The bigger the amplitude, the more loud it is, or what we call sound intensity. Smaller the amplitude, the less intensity. All right. So what we're going to do here today, why can't I get my camera right? What am I doing? There we go. All right. What we're going to talk about today is these amplitudes here. So let's say, for example, amplitude A. So I got my little grid here. So I'm going to say this one has an amplitude of +2. All right. I say plus just because give it a direction, and it's 2 because it's 2 squares. And this one is also +2. All right. So what I'm going to do is I'm going to run this. And what it's going to do is it's going to give me, or these waves are going to meet. And we're going to see what happens when they meet each other. All right. Whoa. All right. So let's look about, whoa, right there. All right. So now we have wave A, wave B, and then right now in the middle, we have wave A and B. All right. So what we have going on here is we have the waves combined, and you could probably count it. This is wave A and wave B combined to make a wave that has an amplitude of +4 meters. Let's just say this is meters. All right. It is combining these waves. Interference is what happens when two waves meet. And this is a more specific type of wave interference called constructive interference. Constructive interference is when two waves meet and they create a larger amplitude. They create this. So if this amplitude equals loudness, I had two sounds, A and B, and when they combined with each other, they created a larger amplitude, or in this case, a larger sound. This would actually make things louder. Well, that would be really bad for headphones to do that, right? So let's kind of reset this here a little bit, and let's reset this a little bit here, and let's talk about what actually happens with noise canceling, which is not constructive. It is the opposite of it. If it's going to let me. Okay, let's just try this all over again here. All right, so in this case here, we're going to talk about noise canceling headphones. The way noise canceling headphones work, the reason why they're expensive, I'll let this load, is I have my speaker here, right? Or I have my headphones. On the outside of them would have a tiny little microphone. And what it would do is if it was picking up a sound, and let's say it picked up a wave that had a very big, loud sound, right? We'll call that, again, wave A. What it would do is once it senses that wave, it's going to spit out its opposite wave or its anti-wave. So if it's got a height of +3, my headphones are going to spit out a wave that is -3. All right. So again, here we have, in this case, wave A, which is +3, and we have wave B, which is -3. Negative just meaning in the opposite direction, right? And so when these two waves meet each other, I'm going to slow this one down a little bit this time. All right. When these two meet each other, whoa, that was actually kind of trippy. All right, let's go back a little bit here. When they actually meet each other, can I get it? There we go. The red is showing wave A going to the right, right? And wave B going to the left. The waves are going to pass through each other because waves are just transferring energy. Energy doesn't have matter. They don't bounce off each other. Energy is waves pass through one another. But in this case, the moment that they meet, our amplitude is 0. And if amplitude determines loudness, a 0 amplitude means 0 sound. And so what happens is when that sound wave comes to my microphone, it spits out the anti-wave or the opposite wave. And when that opposite wave cancels it out, all right, it cancels out that outside wave. So I don't hear the noise coming from around me, because this is what we call destructive interference. Easy way to remember the difference between constructive and destructive is constructive, you're taking 2 and building a bigger wave. Destructive is you're taking 2 and you're making a smaller amplitude. You're destroying the amplitude into smaller. Now, it's not always equal, right? So let's see if we can try this one more time. Let's see if it's going to let me do this. All right. What if I created a wave that, let's say this one is, we'll go 3, but this one is only -1.5. All right. What's going to happen then? All right. So when these two waves run against each other, this is going to be destructive interference, right? And so what I'm going to get here, see if I can get a good spot of it right there. That's going to be about as close as I'm going to get. All right. So in this case here, I started with a +3 amplitude and a -1.5 amplitude. And so +3 and -1.5, I've created a wave that has a +1.5 amplitude. All right. So it's going to be quieter than the +3 wave, but it's not going to be quite as much. So this is what happens when two waves meet. It's called interference. We can either have constructive interference or we can have destructive interference. And remember, if in our constructive amplitude or destructive amplitude, and amplitude determines loudness of the sound. So that talks